Hello everyone, welcome back to Think Lab by Saurabh. So in the previous lecture, we learned the fundamental of Pythons and NumPy. So now we are moving one step closer to real world machine learning. So in the today's lecture, we are going to learn pandas and the data handling. So Panda is one of the most important library for machine learning and data science. So before training a machine learning model, we first need to load the data. Then we have to understand the data. After that, we will perform the cleaning of data and prepare our data, and finally pandas help us to perform the almost all these tasks, right? So by end of this lecture, you will know how to create a data frame, load the data set, inspect the data, and select the columns filter as well as row filter, and how can we handle the missing value, and how can we prepare the data for machine learning, right? So now we are going to open the Google Colab, and first we are going to write here the import pandas, right? Because we are because we have to understand the how can we use the panda for the machine learning. So simply I'm going to write here import pandas as a PD. So you can see this is Google Colab, and now we are going to write here import pandas as a PD. So, so let's start the importing the pandas. So here we write import panda as a PD. So panda is a library name and PD is the short form, right? And this is simply a shorter name that can be used instead of writing the panda. So that's why we are defining panda as a PD. So next time we will use PD every time in place of pandas. So instead of writing pandas.dataframe, we can also write pd.dataframe, because PD is a short name for pandas. And the second line we are going to write here, though, we are going to write the check the pandas versions, right? So we can simply write here print pandas version PD underscore pandas. So now we are going to write here, first you let me run this command. Now we are going to write here the pandas versions PD dot versions. So I'm also going to execute these things, right? So this second line print the install pandas version. So this is useful because different version of pandas, sometimes they behave different ways. So that's why we are going to check here the pandas versions, right? Now after these things we have to understand the pandas series, right? So before understanding the data frame, we need to understand the pandas series. So I'm going to write here about the panda series, right? So what is a series? So series is basically one dimensional label data structure, right? First we understand the series, then we move to data frame. So you can see here we after the running this code, we got the pandas version is the 2.2.3, right? So now we are going to write here the panda series, okay? So uh, series is a basically one dimensional label data structure. So you can think of it's a single column of data. So how can we define a series here, right? So like a list, in the previous lecture we'll discuss about the list. So we will create a list inside the pd.series function. So series is basically one function here. So you can see we have to import the panda as a PD. So I'm going to write here the panda as a PD. So first we are going to write here the panda as a PD, and we defining one variable is, and we are writing here pd.series, and inside this series we are going to write creating one list. So this is a list here, right? And now we are going to print the age, because it's inside this age variable we just define here, we just declare the different data elements inside the list, okay? And we using the functions series, and this function is available in the PD. So PD represent the pandas. You can see in the writing the PD, so it's represent a powerful data analysis and manipulation library for Python, right? If you click on the series, it also show you the suggestions, okay? So you can see here this is a series. What is a series here? One dimensional ND array with access level including the time series, right? So you can also you can see the all the kinds of how to write a code, and also you get the information about the series here. If you scroll down, so they will tell you the how to perform the series. So you will got every information about, you can see you are writing a pd.series here. So this syntax we are going to use here. So this Google Colab give you the all the informations about, all the modules and all the functions inside the Python library. So that is the beauty of this Google Colab. You can get every information regarding this thing. You can getting the syntax here also, right? So let me run this code here. So you can see here we got this data. So here we created the Python list. What is the meaning of this code? Here we are creating a one Python list containing 5 pages, and then we pass this list to pd.series. So pandas convert the list into the series. So notice that panda automatically create an index, and this index start from the 0. So the first value has an index 0 and second value has an index 1, and so on, right? So now you are going to create another example. So now we are going to write for, we can also use here, inside only we define here the only the form of the series here. So now we are going to also define the index here, right? So first thing, the panda convert in the list into series, right? And the indexing start from the 0. So we can also see the indexing. So how can we write here? So this time we have to, after this writing this pd.series, we have to also define the index here. So I'm going to write here, you can see I'm going to write here series plus index. So this is our series. So this series define the list here. After that we are going to define the index here, right? So if you run this thing, so you can see here, this is, you will get the index like, index A, right? It's getting the 20. So here what we are doing here in the backend, so we also provide our own index. So here we use the data student, we use the student id as a b c d. So this demonstrate an important feature of panda. So panda allow us to work with the label data instead of only the numerical positions, right? So you can see we got the all the data in terms of their index. After the series, we got the information about series. How can we just use the how can we see the data in form of series, right? We also use the indexing here. After that we are moving to data frame. That's the most important, because everywhere in the machine learning we will use this data frame, right? So let me write those things here. So let me write here the data frame here. So I'm going to write data frame. So let's move to the most important pandas data structure, is the data frame. So data frame is a two-dimensional table. So you can think it like an Excel spreadsheet or a database table. So it's contain the row and column. So in the machine learning, most data set are represented as the data frame. So how can we create a data frame? Suppose we have going to define one dictionary, and inside the dictionary we are going to write here the all the information. So we are going to store the name is, study hour score, right? So we are going to define one variable here, and after then inside the one variable we are going to create one dictionary here. So you can see we are writing here the name is defined in the form of list. So this is name is a string type. We are taking the as, so we are taking the this is the int in list. Okay, we are defining the list, right? Also we for the study hour we are also defining here the score, we are also defining here, right? So now after this we have to create one data frame. Okay, so you can inside the data, what is a data frame? Basically two-dimensional table. So we are going to create two-dimensional table using the data frame function. So how can we write here? So if we are going to write here, first we will define the one variable name. So we are going to write here the variable name is the df. After this we are going to write here the variable name as a df. And what is a pd here? This is pd is for pandas, right? We have already defined the panda as a pd. So I'm going in place of pandas, I'm directly writing the pd, right? So you can see here we are writing here the pd. So what is the here? You can see we are writing simply pd.dataFrame, right? So this is the our, we are using, if you click here, just put the cursor here, so it will give you the Google suggestions, Google Colab suggestion. Here you can see it's showing the data frame, right? So let's wait, it will give you the suggestions, but not it's giving. I think there is some kind of internet issue problem. So once you just scroll your cursor here, you will get all the informations. So let me run this thing here, right? So you can see you are able to, you have created the data frame. But how can you show your data frame? Because we have to define the print df, right? You have created a data frame, but you have to show that data frame. So how can we show? So simply write the print df. This is df is our data frame. So let me print here. So you can see here you are able to see the our complete two-dimensional data frame, right? So what is the meaning here? So we created the Python dictionary called data, and this dictionary contained the 4 columns. The first column is the name, second column is the age, third column is a study hour, and the fourth column is a score. So each column contained the 5 values, right? So next we use the pd.dataFrame. So this convert our dictionary into the panda data frame, and finally we use the print df to display the complete data frame, right? So this is the most important thing. Okay, now we are going to understanding about the data. Okay, so how can we understand about the data? Suppose I want to check the, if you are going to check here the first 5 row. Okay, so let me write here these things. We are going to understanding about the data. Okay, see, so I just if you want to if you have a large data, you have uploaded the data in using the pandas, and you want to see the first 5 row. Okay, so how can you write here? So simply you can write the print first 5 row. So you can see I'm going to write here the print first 5 rows. You can see here we have created a data frame. After that we are writing here the first 5 row. If I am going to write here first 3 row, so it will show you the only 3 row here, right? But it's still showing the 5 row. Why? Because if you write the head here, so it will so first we have to remove this thing. Okay, so now we are going to remove this thing, and now we are going to print. So it's showing the first 3 row, but we have to use another function here. Okay, so in place of first 3 row we have to write here the print df head, right? Inside the head we have to print the 3. You can see if you are going to run this program, is run this code, so you will get the 5 here, because if you don't pass any argument inside the head, it will show you the 5. If you put here the 3, it will show you the 3, right? Now you can see this is a 3. So by default it is take the 5. So head function display the first 5 row of our data set by default. This is one of the most important functions I recommend using when you have load your new data set. So it's give a quick idea about your data looks like, right? So if you also want to check the first last 5, so how can you take the last 5? So you can using this tail function. Had we define, if you are going to see the last 5 lines, so you can use the tail. So if you print here the tail, you can see here we got this information. If you are not writing here any default value, if you are going to write here the 3, it will give the 3. So by default it's taking the 5, right? So it's display the last 5. So now we are going to check the data set shape. So how can we check? So simply we can write here the shape, and we will use the function df.shape, right? So we can simply write here the df.shape, right? This is shape is a one function here, right? So you can simply write df.shape, so it will give you the answer. So let's look at the shape of a data frame. So shape tell us the number of row and column. In our example we have a 5 row and 4 columns, so output is a 5 into 4, and the first number represent the row and the second number represent the column. So okay, so that's why this displaying here a 5 into 4. This is first is the row, 5 is the row and 4 is the column, right? Now we are moving now we are moving to, if you want to see the shape of a row and columns, so you can simply write here the individually number of row and number of column using without, if you want to print without the shape function, so that time you can use here this row and columns, right? So you can see it's displaying the 5 row and 4 columns. Okay, right? So now we want to check our columns name. So that time you can use the df.columns, right? So column attributes give us the name of all the columns in our data frame. Suppose how we want to check all the columns name of our data frame. So how can we check here? So simply we can write here the df.columns, right? So let me write here the df.column. So simply we are going to write here the df.column. So you can see we are writing the df.column. So you can see this is the column name. Name is study hour and a score. Okay, this is we got here. So now we are moving to next one, right? selecting the multiple columns, right? So if you want to select the, if you want to multiple columns, if you want to multiple columns, so we can provide the list of columns name. So here we are selecting the two columns, name and score. So you can simply write here the print df, and simply inside the list you can write the name and score. Okay, so I'm going to write here name and score. So we are going to print here name and score. So you can see here we got the information about the name and score, right? So okay, this part is completed. Now we are check the data set information. So there is one function, name of the function is info. So this tell us the entire number of columns name, as well as tell us how many none value are present, and also tell us the data type of every column. So when we are working with the real world data sets, so I usually run the info very early stage for the analysis process. Okay, so now we are going to check here the df.info, right? It will give you all the information about your data set or data frame. So you can see here we are got all the informations about the data frame. This is a name, has a total 5 values, right? Data type is object, age has a 5 values, and also we got the every data type here, right? It's also so that this have 4 columns and 5 row, right? Now we are going for the perform the statistical summary, right? So there is one describe function in the pandas. So simply we can write the print df.describe, right? So now we are going to write here the df.describe. So we are writing df.describe in so it will give you all the statistical parameter. You can see here it will count, you give the mean, standard deviation, mean 25%, 50, 75 and max, right? So describe function give a statistical summary of numerical column. Is include the count, mean, standard deviation, minimum value, quartile, maximum value, and this give us a quick understanding of the distribution of a numerical data, right? Now we are going to selecting the row with the iloc function, right? So let's learn how to select a row. So pandas provide the two important method. One is called loc and another one is called the iloc, right? First let's understand the iloc, right? Because iloc is a primarily based on the integer positions. So if you want to check here to the positions of particular integer, right? So we are going to use the iloc functions, right? These are the important function or basic functions you have to use in your upcoming machine learning model. So simply writing the iloc function here, you can see it's displaying what is the iloc is displaying here. So this select the first row, and remember that the Python indexing start from the 0. So index 0 represent the first row. So you can see with the help of iloc, if you're writing here the iloc 0, so it will show you the complete first row. Name is name, study hour and score. If you see the data frame inside, you can see this is the data frame. This is the first row. Rahul, name is the Rahul, age is 20, study hour is 5 and score is 50, right? So you can 75, sorry. So you can see here we got all the information with the iloc, right? This is the very important function in pandas library. Okay, now we are going to understand the, okay, you can also use here like selecting the row from you can also select the multiples row. So we are selecting the row from index 0 up to like you can take the up to anything, but not including, right? So not including the index 3. So I'm going to write here the 0 to 3 using the iloc function. So you can see here it will display all the 3 row. So you can see here is showing here the Rahul, Priya and Amit and all the details of this is study hour and score, right? We got these things. So after that we are selecting the row with the loc. In place of iloc, you can also use the loc, right? So loc is a basically label based. Okay, so first let me write here. So after that we will understand what is a loc function. So you can see here this is we got the information about the age. Her name is Rahul, study and hour. So you can see what is the difference here. So loc is a label based. In our current data frame, we default row label are also 0, 1, 2, 3 and 4. So loc 0 select the row whose label is 0, right? If you are writing here the log in place of 0, if you write here the 1, so it will show you the next row. So I'm going to write here the 1, so you can see it's give the next row, right? So this is important of this iloc and log. So in the if you see the simple difference, going to write here, so iloc work on the integer positions, right? In the form of text I'm going to write here. So iloc is basically used for the integer positions, log is used for the label, right? This is a main difference. Okay, so now we are going with the working with the filtering data. So we are reaching one of the most useful feature of pandas, filtering the data. So in the machine learning and data analysis, we often need to select only the row that satisfy a particular conditions, right? Suppose if we are going to define here, we are going to define one score here. So I'm going to define one variable. The name is the high score, and here putting the condition inside our data frame. Score is a one column is there, so we are taking the inside the df we are writing a score is greater than 5, so 75. So it will show you that particular result, right? So let me print the highest score, because we have only put the conditions here. Let me write here this complete score. So we are going to print here the highest score. So you can see this Priya and Neha got the marks greater than 75%. So score is 85 and 92, right? So we are here selecting the student whose score is 75. So DF score select the score columns, and then we apply the condition greater than 75. So Panda check this condition for every row, and finally we use the condition for filter the data frame, right? So you can also use the study hour for this. So you can simply write here, if you want to write in the one line, so you can directly write the print function. Okay, so you simply write the print function here. So you're going to write here print df study hour greater than 5. So you will see we got all the result about. Okay, so within the one line you can write this code. Okay, so now we are going with the multiple conditions. Okay, so we can also write multiple conditions, like if you are going to define one variable named filter data. So you see, if you are going to write a multiple variable named filter data, and we are writing here the df, and inside putting the two condition, age is greater than, it should be greater than 21, and score should be greater than 70, and we are going to use the filter data, right? So what is the filter data? That is a variable name here. Okay, so we got this result. So we can also combine the multiple conditions. Okay, so where we can also looking for the student whose age is at least 21 and whose score is greater than 70, and this this symbol represent the and. Use this ampersand. You can see we look like the and. We call the ampersand symbol, so this represent the and. So using multiple condition in Panda, we generally place each condition inside the parenthesis, right? Now we are going for the missing value. Okay, so I'm going to write the next now we are going to learn the new topic here inside the data frame only, missing value. Okay, so how can we check the missing value in the data frame using the pandas, right? So real world data set are rarely perfect. We often have a missing value. So missing data can create a problem with the training machine learning model. So we need to identify and handle the missing value. So how can we use this missing value here? So we are going to define one one data frame here, and then we will see, we are going to write here one data frame, because in our data frame we don't have a missing value. So we have to take that kind of data frame, they have some kind of missing value, right? So we are going to define one data missing variable here. This is a variable name. Inside we are putting the one data name is Rahul is given. Age, you can see inside the age there is a none. This is a missing value. Score is also none. This is also a missing value. And we are defining this df dot missing and going to print this data frame. So now you can see we got this kind of data. We have here two missing value. One is in age, another in is score, right? So we have intentionally created this missing value using the none, and Panda represent this missing value numerically as none, right? So how can we detect the missing value? right? So there is one functions, the name of function is the is null. So is null check whether its value is missing, right? So now we are going to print here df, because our data, what is the data frame name, df underscore missing, and after that we will use write the is null. So you can simply write df underscore missing dot is null, right? So now we can see here, we can see its goal here, you can see the missing value is checking this true condition. It means we have in this column we have a missing value, right? So is null check whether each value is missing, and it return true when a value is missing and false when it is, right? It is not, sorry. So it's returned the true when there is a value is missing and false when it is not, right? So you can also check the sum. There is another function, the name is the is null sum, right? So this is more powerful function here, because this is even more powerful because is null identify the missing value, but sum they count them, right? So that's why we are going to write here is null. After that we are going to write the num. So that will count the how many is null. After that we are going to write the sum, right? So they will count the total missing value here. So you can see in the age there is one missing value, in the score there is one missing value, right? So they will count the function. So because we combined the two things, one is null that identify the missing value, and the sum count them. So we can quickly see how many missing value exist in each column. After that we can also fill the missing value, right? So you can using this fillna functions, there is one function the fillna. With the fillna we can fill the function with help of mean. Okay, we can take the mean of all the score and fill those things. So how can we write here? So we are going to define one variable df dot field, right? So you can see here we are going to write here. So you are going to write here using the is null. So we are going to define the df dot field. We are taking the missing copy of this data frame, and inside we are going to write df dot field age, and inside this this age we are going to fill this age with the mean, right? So what we are performing here, one approach is handling the missing numerical values, replacing them with the mean. So first we create a copy of our data frame, then we select the age column, then we use the fillna to replace the missing value, then inside the fillna we provide the mean of age column, and we do the same thing for scroll. This is called the mean imputation, right? However, number that mean imputation is not always the best choice. So the correct method depends on the data set in machine learning problem. Or if you not want to fill the missing value, so you can simply drop the missing value, right? So there is for dropping there is one functions. So let me write those things first. First let me execute. You can see we can successfully fill this missing value with the mean, right? If you not want to fill with the mean, so you can perform drop missing value. So now we are going to learn here how can we drop the missing value. So there is one function for the dropping is the df underscore missing drop na, right? We call it dropna function, right? So we are now going to run this thing. So you can see here we drop that function, right? We dot so you can see there is no missing value here in our data set. So simply we perform the drop here. So this is the another approach to remove the row containing missing value. So we can do that using the dropna, but we should be careful if the data set contain many missing value. So drop row can result in losing a large amount of useful information, right? After that we are going to use the how can we sort the data. So for sorting the data, we have a function name is the sort underscore value. This is a one important function, so we will also learn this. All this function that will be used later in our machine learning code, right? When you are going to build a machine learning pipeline, so that time every function will be used of this pandas library, right? So now we are going to just use the df underscore sort, right? So this is the value, the sort underscore value. This is one function. So we can sort our data set using the sort underscore values. So here we are going to sorting according to score columns. So by default the value are sorted in ascending order, right? If you write here the sort underscore score, so that will perform you the ascending order. If we are going to write in the descending order, so simply you can put here the descending is equal to false, right? You can see here simply we can write here descending, because by default it's descending, right? By default it's ascending, so you can simply add here ascending underscore false. It means it will give you the descending, right? So you can see here this graph, this value is ascending and this one is the descending, right? So by using one command you can just sort the data. Okay, now we are moving to the creating a feature and target. So let's connect the pandas directly to machine learning. So in the supervised machine learning, we normally have a two important component. One is called the feature, another is called the target. So feature are the input variable that the model used to make the predictions. So the target is the value that we want to model to predict. So how can we define the feature and target? So simply we are going to write here, suppose we will define here x represent the basically input feature, right? And y represent the target. So simply we are going to write here the two variable. Okay, I'm simply going to write here the two variable x and y, right? So what is the x here? X represent our input feature. We selected the input feature here, the age and study hour. You can see in the df we are writing the, in the df inside we are writing the list age and the study hour. After that we are selecting y represent our target. So our target we are taking the score. Okay, so if you see the conceptually, so it will be look like this, right? This is the input and this is the output, right? So if you see the this is the basically this is a feature and target, but how can we check it? So if you see the workflow here, so both are this input and we send input to machine learning model and give you the output. So this is a x and this is a y, right? So you can see this is our features and this is target. So from the data set we divided the data into the feature and target. Okay, so this will be this kind of concept we will use in the machine learning. Now we are going to use the CSV file. Okay, so how can we read our CSV file here? So for for reading a CSV file, we can create a data frame manually. So but in the real world, let me write here how can we read the CSV file here. I'm going to take the next topic inside the pandas. Okay, reading a CSV file. How can we read the CSV file? Because every time we will not create the data frame, we have to take the data from external sources. So external sources may be the CSV or text file. So until now we created a data frame manually. So but in real world machine learning project, data set usually come from the different files. So one of the most common format is a CSV. CSV stands for comma separated value. So how can we use this thing? So first we can also use here, you can see we can also convert into the CSV. Our data frame we can also convert into the CSV file here. How can we convert those data frame into the CSV file? So let me write this code here. First thing we will do here, we can simply write here the df. We can simply write here the df to CSV, right? We are going to write here the df to CSV. What is the meaning here? So here we are saving our data frame as a CSV file, right? And this 2 underscore CSV is the panda functions that used to save a data frame as a CSV. Okay, and this index false, it means that we would not want panda to save the data frame index as additional columns. Okay, so now we are going to save the CSV file. For saving, we can write here the print CSV file successfully created. So now we can see the CSV file is successfully created, right? So we can create we have already created here. Okay, so if we have a CSV file, so how can we load the CSV file? So that time we will use this. We have a CSV, suppose we have a CSV file. So how can we read those file? So reading the CSV file, we have a functions here. The name is function is pd.read, right? pd.read underscore CSV, right? So now you can see here this data is now converted, this data was converted in CSV. Now using this pd.read functions, we can see we get our data here, right? So now we can read the CSV file using the pd.read underscore CSV function. So this is one of the most common pandas command, right? command we will use in the machine learning project, right? So if you see here the complete data handling flow, right? So I'm trying to write the whatever we taught here in this till now. So now we are going to combine the everything what we learned into the simple machine learning data handling workflow, and we are going to put into the one place so that you can understand what we perform here, right? So I'm taking going to take the all the code together, right, and also understand the complete pipelining here. So right, you can see here, first thing what we have studied here, first thing we have load the data set here, right? So this is this is an example of how pandas fit into the machine learning workflow. So first we load the data set, second we inspect the first few row, then we check the safe here, right? You can see here, first we load things, then we see the first 5 row here, right? Then we check the shape, then we check the informations, after that we perform the statistical summary, then we check the missing value, right? We use this is null sum function for the missing value, then we select the features, then we perform the target, and we are going to print this feature and target, right? So finally we separated our feature and target, and after this step we can move toward the machine learning pre-processing and the model training, right? So what we learned today here, so we have learned this, before finishing this today lecture, let's quickly revise the most important pandas command. So we learned here the pd.series, right? pd.dataframe here. So let me write here the complete python function that will be used till now we have used here. So we use this function pd.series, okay, pd.dataframe, okay, pd.head, pd.tail, df.set, after that df.describe, columns head, iloc function, log function we have used. So this command will form the foundation of our data handling skill. So you don't need to memorize everything today. The most important thing is to understand what each command does and practice using it. Okay, so let's understand why panda is so important for machine learning. So machine learning model cannot simply take a messy real world data set and start learning. So we first need to understand the data, we need to load it, we need to inspect the data, we need to identify the missing value, we need to clean the data, we need to select the useful features, we need to separate the features and target, and only after preparing the data can we send to our machine learning algorithms. So panda act as an important bridge between the raw data and machine learning. That is the most important. Panda act as an important bridge between the raw data and the machine learning. So today's lecture we have learned the pandas and data handling. We started with the series data frame, then we learned how to create and inspect the data frame, then we learned the head, tail, shape, column, info, describe this function, then we learned how to select a row and column using the log, iloc, then we filter the data, we check the missing value, we sort the data, we separate the features and target for machine learning. Okay, so in the next lecture we will go one step further. We will learn data processing feature engineering, where we will prepare our raw data for the machine learning model. So if you are following this complete machine learning course, so make sure you practice today pandas command, because we will use them separately in upcoming projects. So thank you for watching. Keep learning, keep building, keep becoming 1% better every day. So I will see you in the next course, next series. Okay, so thank you for watching. Happy learning.